this lightweight device carries a 56 million pixel camera, offering a true panoramic view. With 360-degree laser horizontal FOV and 40-meter scanning, it captures every subtle detail. Effortlessly maneuver through the areas, acquiring dense point clouds easily. And yes, it's absolutely safe. Pick up the Leica K1. Traverse the streets and alleys. Focus on your points of interest. You'll never miss every beautiful detail. Real-time rendering of true color point clouds ensures even beginners can create exquisite 3D models. Meanwhile, it's a professional surveying tool. Its mobile handheld operation bids farewell to the tedious and inefficient traditional survey. With built-in multi-slam algorithms, it helps to achieve centimeter-level precision scan in various indoor, confined, structurally complex, and dark scenarios. It's not only a tool for productivity, but also an engine for creativity. It all begins with Leica K1 in your hands. Introducing Leica Kitty K1, a compact handheld 3D scanner by XGRIDS. Sleek design and user-friendly operation, Leica K1 transforms professional 3D reality capture into a remarkably simple process. Weighing less than 1 kilogram, this lightweight device carries a 56 million pixel camera, offering a true panoramic view. With 360-degree laser horizontal FOV and 40-meter scanning, it captures every subtle detail. Effortlessly maneuver through the areas, acquiring dense point clouds easily. And yes, it's absolutely safe. Pick up the Leica K1. Traverse the streets and alleys. Focus on your points of interest. You'll never miss every beautiful detail. Real-time rendering of true color point clouds ensures even beginners can create exquisite 3D models. Meanwhile, it's a professional surveying tool. Its mobile handheld operation bids farewell to the tedious and inefficient traditional survey. With built-in multi-slam algorithms, it helps to achieve centimeter-level precision scan in various indoor, confined, structurally complex, and dark scenarios. It's not only a tool for productivity, but also an engine for creativity. It all begins with Leica K1 in your hands. Introducing Leica Kitty K1, a compact handheld 3D scanner by XGRIDS. Sleek design and user-friendly operation, Leica K1 transforms professional 3D reality capture into a remarkably simple process. Weighing less than 1 kilogram, this lightweight device carries a 56 million pixel camera, offering a true panoramic view. With 360-degree laser horizontal FOV and 40-meter scanning, it captures every subtle detail. Effortlessly maneuver through the areas, acquiring dense point clouds easily. And yes, it's absolutely safe. Pick up the Leica K1. Traverse the streets and alleys. Focus on your points of interest. You'll never miss every beautiful detail. Real-time rendering of true color point clouds ensures even beginners can create exquisite 3D models. Meanwhile, it's a professional surveying tool. Its mobile handheld operation bids farewell to the tedious and inefficient traditional survey. With built-in multi-slam algorithms, it helps to achieve centimeter-level precision scan in various indoor, confined, structurally complex, and dark scenarios. It's not only a tool for productivity, but also an engine for creativity. It all begins with Lycosol K1 in your hands.
Agora sim. Bom, ok. Meu microfone não estava funcionando, desculpa, então vamos começar novamente. Bom dia a todos. Meu nome é Erick Martins, sou CEO da Plankus, e vamos dar início agora ao nosso webinar de lançamento da XGRIDS aqui no Brasil. A Plankus tem o prazer de poder representar a XGRIDS aqui no Brasil e trazer os scanners da XGRIDS, que são scanners revolucionários, que estão mudando o cenário da captura da realidade no mundo todo. São pioneiros na utilização de 3D GS, processado diretamente do resultado do escaneamento, e é algo que não temos aqui disponível no Brasil até então. Então, é um lançamento aí inédito que a gente está fazendo aqui agora em primeira mão nesse webinar. E nós vamos estar também na Mundo GeoConnect 2025, a feira de geotecnologia, que acontece junto também com a feira Drone Show e outras feiras dessa área nossa, né? E a gente vai estar fazendo o lançamento. Eu vou falar um pouquinho mais da feira mais no final da apresentação e fazer um convite para vocês também. Então, fiquem até o final para que vocês não percam esse convite que a gente vai estar fazendo. Hoje quem está aqui comigo é a Mindy Li. Ela é diretora de marketing e desenvolvimento de negócios da XGRIDS. Ela vai fazer uma apresentação para a gente, vai ser uma apresentação em inglês, e quem tiver dúvidas, quem conseguir entender o inglês, tiver dúvidas e quiser colocando nos comentários, eu peço que vá adicionando. A gente vai ter um momento no final para tirar dúvidas, né, conversar um pouco mais sobre as soluções. A ideia é que vocês possam participar também e adicionar comentários e a gente enriquecer aqui esse momento. A Mindy vai fazer uma apresentação para a gente em inglês. Esse vídeo está sendo gravado e vai ficar disponível depois para vocês. A gente vai adicionar legendas, não vai ter legendas aqui agora, mas a gente vai adicionar legendas, então depois vocês podem voltar e ver algum detalhe que quiserem confirmar. Certo? Mindy, welcome to the stage. I was doing a presentation in Portuguese, so everybody could understand, and I'll give you the stage so you can start.
Yeah. So hello everyone, and thank you, Eric, and thank you, Plankus, for inviting me to this webinar. And today, it's my honor to be here and give you a presentation and the introduction to talking about XGRIDS technology and how our devices and technology can deliver a very good result with all this 3D presentation and measurement results. And here now I try to present my screen. Wait, I should admit a little bit. Can you see the screen? If so, I will start on my presentation. Eric, can you see the screen? Yeah, so firstly, XGRIDS. As many people know that we manufacture and sell that 3D scanner. However, we are not only scanner manufacturers.
Can you hear me?
Are like 3. Yes, we can hear you.
We cannot
can you see
your
that screen?
Not yet.
So I think you should present the whole screen to that.
Yes.
Yeah, exactly.
No, that's going to appear. All right.
Yeah. How about now? Can you see that slides? Yeah.
Yes.
Okay. So I will start from the very first. Thank you so much. As you know, and thanks to the Plankus that you get to know that XGRIDS scanners. And however, we are not only the scanner or hardware manufacturer, but also the 3D intelligent technology and a solution provider. So other than that 3D scanning devices, we also provide a whole reality capture software and some application SDKs, not only in the software itself, but also all the application tools. And some slides talking about that whole backgrounds and the team of the XGRIDS. Even though the team is very young, the team founded in 2020, but we have long experience in 3D reconstruction. And a core member of the team come from DJI, and our founder, Dr. Zhao Kaiyong, coming from he is the first product manager of the DJI Terra, which is a very popular 3D reconstruction and photogrammetry software. And he also have experience in the high performance computing and distributed computing and high performance experience in that robots and some spatial technology. And that's the opportunity we see in this industry developments. So from that PC computing period, we find that people use that manual modeling ways to do the 3D environments. And when it comes to mobile computing times, people got that photogrammetry things and some automated 3D modeling methods. People could use that drone for that large-scale cases, large-scale environments scanning and reality capture. People also use that photos for different environments capture. But when the period or the era come to that spatial computing period, we find the AI and deep learning technology helps a lot with that immersive 3D contents. When the immersive devices like the VR headsets and AR glasses have great developments, we find that there is a lack of the 3D content. So that's a very big gap between that content's needs growing between that growth with that 3D contents generation difficulties. So that's why we find there must be some techniques and tools to help people create 3D modeling and to capture the reality in a more efficient and quick way. So based on this all core technology behind XGRIDS, we find that we could build some very great tools, which is that the core technology behind XGRIDS is like high precision real-time 3D reconstruction. Other than that photogrammetry methods, we also combine the LiDAR with the different kinds of sensors together, which means that multi-sensor SLAM. And we also have that distributed high-performance computing methods to tackle with the intensive data computing things. And we also use that for some 3D data collection procedural and with the deep learning AIGC powered tools and methods. Over the XGRIDS scanning devices can also perform reliable and robust in different kinds of environments. So that's the product portfolio of our technology. From that data acquisition to data precision and application, we have different kinds of tools to meet the requirements and tackle the issues of that accuracy, the balance of the accuracy and efficiency and the labor-intensive software and some deep learning curve. And we try to bridge the gap between the physical world and digital world. So from the data acquisition period, we got handheld scanner to do the data acquisition in a people's way. So before that, people got like photo shooting ways like the cameras or iPhones, and people got drones or the airlines in the sky. But in the people's eyes way, in this scale, it's lack of some devices or the technology to do the reality capture. So that's why we choose that handheld scanner as a starting point to get into this technology. And then in the data processing procedural, we got a point cloud processing software, as well as you see that LCC, the Lexo Sever Color. It's a new way to do the 3D reconstruction called 3D Gaussian splat, and I will do some further illustration in the following parts. So that after that data processing procedure, we go that to that data application part, because other than that, to getting the 3D data, to understand and better apply that 3D data into real world is the more important thing behind that technology. So our solution provides this kind of thing. Firstly, we have a stable and a reliable system for that mobile scanning. And then we also try to transmit the data remotely with different module combination. And we are also the first company and a solution to reach that to real-time modeling, to convey 3D, the real-time point clouds within the devices, because all the computing things happen on boards. So that's why we call it the real SLAM themes, all the data processing on boards, and you can get point clouds right after you finish the scan. So the different results of the solution would be like, firstly, we got point cloud, and we combine the RGB camera with LiDAR. So we got a true color point cloud right after you finish the scan. And also the mesh models. So from the drone, you can get some mesh models with all the buildings and environments in a very quick way. But in some indoor cases, drone always perform worse. But we got handheld scanner to do that mesh inside the house or some inside or indoor cases. Then we got LCC, which is a much more photorealistic and film-grade 3D models. And all these models can also be imported in different kinds of terminals and devices. And you could also use that different platform or something like that, Unity and Unreal Engine, WebGL to do the further application. So that's the two parts of our technology. First is that easy capture with that spatial camera we call scanner. And we also got simplified workflow with all the AI automated tools. So here are some highlights of the mobile scanner itself. Firstly, it captures reality instantly, cut the project time by 80%, and then it processes automatically, especially for some filtering and dynamic object removal very easily, and you can also share globally. And here I like to introduce two very important devices we have. The first is that Lexo L2 Pro, which we call flagship, and it's much more designed for some surveying industry and the measurement purposes. And its working range from 120 meter to 300 meters, and its relative accuracy up to 1 centimeter. And you also got option with that 32,000 to 64,000 points per second scanning efficiency. So that's, you could use that for some topographic survey, mining, agriculture, and forestry survey. You could also use that for some very large scale and complicated cases like the parking lots, underground parking lots, and mining tunnels. And we just launched it last September, but before that, we got Lexo L2 and Lexo L1 as the first devices which can convey the real-time color point clouds. So that helps the surveyors could inspect their data on sites very quickly, and to make sure that they get the correct data before they bring all the data back to their office without any space has been lost. And when we comes to that L2 Pro, you get a real-time data compared to those previous devices can conduct the post-processing, so that you could compare the post-processing data with the L2 Pro real-time data, which is enhanced efficiency in a great way. And you can also get a real-time absolute accuracy of 3 centimeter. Its result very crisp and beautiful. And you can also download some sample data from other websites, and you can also find some help and book a demo with Plankus. And then we got Lexo KDK1 is a much more like professional 3D results from a 1 kilogram devices. It's very lightweight and compact, but its working range relatively smaller. It's 40 meter range, but its relative accuracy is also up to 1.2 centimeter. And it's good enough for most of the indoor and medium-sized cases. So compared with the L2 Pro, Lexo KDK1 is much more like entry-level surveying devices. But it's also very suitable and available for some other industry people, like the filming industry. They also use that for some filming backgrounds or backdrops, reality capture. It was widely used in underground mapping, cinematic modeling, indoor measurements, and cultural tourism projects. And it's also very popular in AEC industry, which means that architecture, engineering, and construction. So in that indoor cases and relatively small cases, compared with some very big parking lots, it's good enough and very reliable. And when it comes to that software part, we got Lexo Studio, which is a very powerful point cloud processing software. You could do that stockpile measurements even on site very quickly. And with that AI-powered algorithm, you could remove the dynamic object automatically. And in some relatively large scale, like some tunnels, you could use that map fusions to do separate scan and match them automatically. And you can even stitch the map from the drone LiDAR with that Lexo LiDAR together. And I would like to highly recommend that Lexo CyberColor, which is very new but amazing technology we bring about in 2023. And it's the world's first SLAM and Applar 3D Gaussian splash product. And with that automated way to generate 3D models, you could do that film-grade 3D modeling. You can also scan large and complex environments in a very quick way. For example, this hangar store, this warehouse, If you do a reality capture with camera, you need to do it like 1 week. But with that handheld scanner, K1 or L2 Pro, you only walk through the whole warehouse like 15 to 20 minutes. And even in some low light and low texture cases, you can also use that lighter combination with that scanner to do the scanning and perform very good. And based on that photorealistic 3D models, you could also do some measurements at centimeter level accuracy. After you get that 3D models, we could do seamless experience in different devices, such as the personal computer, cell phones, and VR headsets. And I will introduce some of our use cases in the following parts. And the whole workflow is very easy to get, even for a girl like me or a lady without any civilian backgrounds. People can get that on hands very quickly. First, we use that handheld scanner in a mobile way. When you move in the site you want to scan, and you can get that in a very quick way. And then you output the data into your PC software. Within that LCC Studio, you could do that automated processing. When you get the whole results from the software, firstly, you could use that local viewer to present the data. And then you could also publish the model, 3D model, as a link that you can share with your friends and the customers. And if you got some experience with that development, software development, you could also use that Unreal Engine Unity plugin to do the further developments. And we recently launched the Revit plugin with that LCC model. So within that Revit software, you could do the scan to beam workflow in a very efficient way. So of all these products and technology, we got 2 core competence. The first is the 3D visualization. So we compare to the traditional solutions. Take this nature park as an example. If we want to do that reality capture in the traditional way, you do that data capture in 1 to 3 days with the daily works. And then we need to do that the data processing and some manual work in more than 10 days. And you must got some 3D modelers or designers, like more than 3 people to do that. But use that the workflow I introduced just now. You do that scan in this 25,000 meter square park. We do the scan in 20 minutes. And the processing would be like 300 minutes. And you got the link that you publish online so that you can share that in a immersive model, and so that your customers and friends can navigate in these models in a very immersive way. And the second core competence is spatial measurements. So other than the 3D presentation and the 3D visualization things, you could also do some solid measurements. Take this as an example. It's a 4-story factory, like 1,000 square meter. And you also do that capture things within 8 minutes with the 4-story factory. But with that stationary scanner or with that other tools, it may take you like 8 hours to do the data capture with a tape or the total station or RDK or stationary scanners. And it will take you like 2 hours to do the processing. And for some very professional guys, they can use that tools like AutoGAT to draw the CAD drawings. But with that XGRIDS solutions, the capture only takes you 8 minutes, and the processing time would be less than 40 minutes, so that you can get that CAD drawings in a very quick way, which enhance the efficiency like 95%. And with all this core competence, what's kind of application scenarios we can reach? Here is the answer. So firstly, we apply the scanners in most of the cases of the AEC industry. So in some architecture and building construction engineering side, we could use that scanner to do the reality capture. You record it over times, and engineers also use that to compare the difference between the different procedurals. And so we also use that for some digital twins conveying. Not only with that point clouds, but also you can build more lightweight mesh models based on the point clouds. And in nowadays, we also use that 3D Gaussian splats, that photorealistic models in a digital twin platforms, so that you can also add different assets, 3D assets and data into the digital twin, so that people can tell what's the difference between the real world and the digital world, and to make decision in a more smarter way. And we also use that for natural resources management and some surveying industry. And also for that photorealistic 3D models, we could navigate and dive into the art gallery in a good way. Then filming and VFX is the new industry we are discover, so that people can use that 3D model as a backdrop, and in a studio that you can invite all the actors in the studio, but without inviting them to the site again and again. So here is the use cases part. So firstly, this case is coming from the Chinese country. Chinese country buildings. With these buildings, they want to do the documentation with the house but the distance between the two houses is too close, so they cannot use the drone. And if they take photos, the photos also get some distortions in the upper part of that buildings. So with that handheld scanner, people that just walk around and inside and outside that building, you get a point clouds, and the designers can extract that the features from that buildings to get CAD drawings, to do the land archive and old building renewal based on that CAD drawings, which is facilitating the engineers' work a lot. And in this case, the second case is about urban underground space renewal. So this is a relatively large scale underground parking lots. So in the past, people use that stationary scanners to do the capture, which costs a lot of time and labor. But within this one is it only take us like 36 minutes to do the reality capture. And based on that point clouds, we also conveying the CAD floor plan. And based on that floor plan, people can make that beam very quickly. So based on the whole 3D modeling, we can do that digital upgrades, and the automated automobile can also do the road planning and fire safety and evacuation planning. And this case is about AEC industry, which facilitates scan to beam workflow, which skips weeks of manual modeling. So in this case, on the left hand, it's 3D models we scanned. It's not a 360 video. It's not the pictures. It's the 3D model we take with that Lexo L2 Pro. And on the right hand here, we combine and overlay. We overlay the beam model with that 3D models. And we also can import the 3D Gaussian splaying models into the Revit, so that if you draw the walls and some equipments, you can get it simultaneously in the viewers we built with that LCC models. So based on all these models, you could also do the measurements and share your measurement result remotely with your colleagues, which are not located here on site. So this would enhance the whole workflow, which you need to communicate with different stakeholders. And another case about AEC is that AI-driven batch modeling. So we do know that BIM, the building information model, is very important for all the procedure of that AEC industry, from that design to construction, to the inspection, from inspection to that operation parts. People need that BIM model for the whole management things, but the efficiency of that BIM model building is quite low in the past. However, these days, we could use that reality capture tool to scan in a mobile way and import that into Revit, so that with the click of the walls, one click of the walls, and you set the height of the walls, you get a whole structure and BIM model of the whole apartment. And this one we also introduced in our new videos with that Revit plug-in launch in Autodesk DevCon conference this year. So with that AI recognition, you could recognize the walls and windows and some feature points in an apartment, so that we could do the semantic point clouds. You could also use that semantic point clouds to help with your manual works. So if you do not trust that the AI result 100%, you could also use that point clouds to facilitate your BIM workflow. And another point is that from that other than AEC and industries, we also help a lot with that stockpile measurements. So you could know your inventory value instantly. In the past, this kind of things is very hard to do because you cannot get the data on site. But with that handheld scanner, you could inspect the data on site, and you could use a desktop to process the data in real time. When you import data into the software, you could get a mesh here and choose different flat or different sections. You could calculate the stockpile very quick. So this function mostly used in the mining, food inventory, and irregular piles measurement, and some construction material inventory measurement. And we also have some cases like natural resource management. So in this case, you can see from that drone photo to the color point clouds, and that the point clouds difference with the heights, so that the designer can join a CAD outdoors like this. And people can also calculate the trees automatically within these point clouds. So we can complete documentation with one scanning, because we combine the LiDAR with the visual sensor together. And people know that different sensors have different advantages. LiDAR perform good in some large-scale cases, and that case with very few features. And cameras can get the real RGB information, and we use that RGB information for that colorization, and so that LiDAR can also get different distance information together. So that with that, all these sensors combined together, the algorithm perform robust and reliable, so that you get two different kinds of data together in one scan. And we also use that for some road assets management and documentation. So you can also mount that scanners on car or drone to get a long way. Even in some automobile and car, you can get in that different like the lamp and some cables together, and the buildings beside that doors. So based on that data we capture, we could do that urban planning and highway maintenance, facility management beside that roads. And another case is very hard for some traditional ways is the mining measurements. So in this case, we combine the data capture from drone with those ones captured with Lexo L2 Pro into the tunnels, so that to make the whole environment visible. When the engineers want to see the structure and to do some education purposes part, they could use the whole models in the office, and they don't need to all the people get in the tunnels to see, and they reduce the underground time. So even though when the surveying and the scanner scanning things inside your tunnels is very dangerous, so the handheld scanner could reduce that underground surveying times, and it also do some predictive safety things with that prediction based on the 3D model visible, so people can do the tunnel measurement, production program, and a production safety plan. And here is the case is the longest tunnels in Asia, so that it breaks the records. It's the longest undersea tunnel surveyed by LIXO L2 Pro, and its extreme accuracy requirements like the less than 20 millimeter precision at 115 meter depth under the floor. So that we also got the real-time monitoring when we do that live excavation program tracking. So it also requires high frequency of the surveying and the scanning. So that's why the L2 Pro is much more reliable in this kind of cases. While some of the manager and engineers use that K1 in some apartments and buildings surveying. And we also perform good in some emergency case. And in this case, in some forensic requirements, people need that documentation for some so afterwards inspections and analysis. So for some accident happens very quickly, and they need to do the documentation and store the site in minutes. But the traditional way cannot do it like this. However, we use that handheld scanner and real-time processing tools. You can deliver an immediate result with that whole disaster sites. And then we also can transmit the data from the dangerous site to the office remote site, so that we can do the remote assessment, let the decision maker can see the dangerous site very clearly. And we can also share the data with multi-agency. Yeah, so with that situational awareness, the better decision can be made. And with that forensic documentation, people can also learn from the disasters. If you get a real-time data, the emergency responses would be better than any other ways. And we also mentioned digital twin. In this case, we do a digital twin from factory floor to a digital command center in 1 week. Like this, it's a 2,000 meter square factory. If you do that with the cameras or some stationary or tape measure, it will take you like 1 week or more to do the scanning itself. However, it only takes us like 20 minutes to do the scan, complete the whole site capture. And the 5 days, we base on that point clouds and a panoramic view and mesh model we generated automatically. The designers make the mesh models for all the elements, so that all the elements 3D modeling can be adopted in this digital twin platform. And we deploy the platform within 1 week. So we also overlay the robotic real-time data with that 3D data, on-site data together, so that the manager can see the real-time situation of their robots, its direction, and what mission it takes, and what's the status of that robots. With the order, is that battery is good enough, or does it convey the correct mission? And all the managers can do that management online, and even in a remote case. People can also do the asset management and simulation with all the robots before they deploy the robot system into the whole factory. And in the energy industry, we can also do a digital twin with that photorealistic and the 3D models. So this part is the point clouds we scan in real time. And in the traditional way, or the last generation digital twin, people may build a mesh model based on that point clouds. However, in the latest version, we could use that LCC 3D Gaussian splat model for that photorealistic presentation. So it's real-time visibilities. You can also combine different like cameras or the sensors in that power plants, so that people can do that automated inspection based on the 3D modelers. And you can also simulate the whole structure and different kinds of cases based on the 3D models to do that field of vision analysis. And combine with the combination of the panoramic 3D view with that 3D photorealistic models, you can also make some education purposes training, and without getting into the site, a very dangerous site. So with all the solid and measurement purposes, we also have some use cases in culture and tourism industry. And people do that one-on-one reality recreation with the cultural heritage and also some art galleries. Of course, for that art gallery and exhibition, not all the exhibit can be kept in a long term, so that within that exhibition period, we could use that handheld scanner to do the scanning and do the processing very quickly, so that all the audience can see that art gallery things without get to that museums. And you could also put that in the VR headsets for those who cannot go on site. And here is the case we put that 3D model in Apple Vision Pro, and you can also use that joystick to navigate or roaming into that 3D assets. So with all these cultural preservation things or the reality recreation, people can do a perfect preservation with not only the cultural heritage, but also the forestry or natural environments capture. And we can make it much more accessible with not only the PC software, but also cell phone and the VR headsets, more immersive, more interactive. And you can also overlay different kinds of information based on the exhibits or the cultural heritage, which is much more smarter tourism. And you can also do some virtual exhibition or different kind of application in some future application or the future devices. Then in real estate industry, it's also very perfect for that online showcase and floor plan design. So this case is a penthouse in the United States. Also with that Lexo K1, very handheld, the compact handheld scanner, you could do that penthouse showcase in your PC website. And within this, you could also do that clipping by yourself. So you don't need to draw the floor plan or to draw the CAD plan, because most of the audience or the viewers, maybe they are not with very little knowledge or backgrounds of that floor planning things, but people can see that more intuitively with that section of the whole villa. And here is another case developed by our very Japanese partners. They use Lexo L2 for scanning and do the LCC Studio for the model training and processing. Then the Unity SDK for their interactive application development, so that conveying a mobile phones application for that cultural heritage. And when the audience or the users get into the house, they can also have some cards or some point of interest to talking more information about the whole tourist attractions and history of the site. And recently, we also have lots of works being done in virtual production and filming and TV sections. Firstly, we use that handheld scanner to do the reality capture. And as you see, you can see the structure, the point clouds, the real-time point clouds in cell phone. And we can put that virtual camera when we project the 3D model we scanned into the Unreal Engine or the LED screen, so that you can use a cell phone to do the reshooting and reacting the scenes and on your PC again and again. So in this case, you could see that this one is the part that we projected the scans. We scan in Japanese. If we scan in Japan, and the people, even though the actor never go to Japan, they can also perform like they are into the temple. So here are some other cases we collaborate with Hollywood directors. And you also use that environmental 3D model to do the VFX, the special effects. And also, before that shooting starts, before the production starts, the directors and the producer can also use the scanner and technology to inspect the whole site, and so that they can do some plans before the production starts, whether the sites need to be decorated or whether the cameras can be put in different positions, and which part is the perfect for all different kinds of decoration furnitures and light setting. So with all this technology, we try to not only capture the reality and getting the data, but also apply the 3D data into different kinds of workflow, and helping the efficiency can be enhanced in different ways. So even though the 3D Gaussian splitting is a very new technology, we try to adopt it and make it much more applicable in different application scenarios. So that's the things XGRIDS try to do. And yes, here's the thing that I want to share today. If you got any questions, I'm here. I'm very glad to answer them.
Thanks, Mindy, for the presentation. It was a great one. Great to hear all about the XGRIDS company and the products. I'm going to do a quick recap in Portuguese for the audience, and if they have any questions, we'll come back with questions.
Yes.
Bom, a gente agradece a Mindy pela apresentação. Eu vou fazer rapidamente aqui uma recapitulação do que a gente viu na apresentação. Nós vimos sobre a história da XGRIDS, né? É uma empresa nova, mas com uma equipe muito capaz, né? O fundador da XGRIDS, ele foi um dos responsáveis pelo desenvolvimento do DJI Terra, que é um software de processamento de fotogrametria da DJI, e boa parte da equipe também veio da DJI. Então, é uma empresa que conta com um pessoal de extrema capacidade, e por isso a gente vê resultados tão impressionantes, né, e uma tecnologia tão avançada que eles estão trazendo para o mercado. Os scanners da XGRIDS foram os primeiros no mercado a conseguir incorporar o processamento de 3D Gaussian Splitting, que é o 3DGS, né, falando o acrônimo para ficar um pouco mais fácil, que é essa visualização imersiva, onde a gente consegue ter um nível de detalhe muito grande, e com a solução da XGRIDS, combinando as imagens e o LiDAR, a gente consegue ter também uma precisão muito grande. Então, as soluções da XGRIDS são extremamente avançadas, com uma qualidade muito grande, e também os scanners, obviamente, né? São dois modelos de scanners, e a gente está trazendo os dois aqui para o Brasil. O Lixel Kiri K1 é o scanner menor, né? Ele tem 1 kg, e ele consegue, com um LiDAR um pouco mais simples, né? Ele alcança aí cerca de 40 metros com o LiDAR, mas você consegue fazer aí 1h30 até de levantamento com uma bateria, utilizando esse scanner. Então dá para poder capturar muito o ambiente. É um que tem um pouco menos de precisão que o outro modelo, mas ele traz uma qualidade também muito grande, principalmente para quem precisa fazer projetos um pouco menos complexos, né? Toda a parte de produção de vídeo, né, que ela mostrou também, a parte de edifícios históricos, né, museus, enfim, toda essa parte de captura da realidade, com o intuito de preservar aquele ambiente, né, de uma forma virtual, né, digitalizar aquilo e ter um arquivo de como estava naquele momento. O K1 ele vai atender aí em boa parte dos casos. Já o L2 Pro, que é o outro lançamento que a gente está trazendo, é um scanner mais robusto, é um scanner que traz uma precisão maior. Ele traz três versões de LiDAR, que você pode escolher entre elas. Uma versão inicial de 16 canais e 120 metros de alcance. Esses 16 canais, ele traz aí 320 mil pontos por segundo de captura durante o escaneamento. E depois a versão intermediária, com 32 canais, 120 metros de alcance. Então, 32 canais vão dar 640 mil pontos por segundo de captura e 120 metros de alcance desse LiDAR. E o mais robusto, com 32 canais e 300 metros de alcance. Então, essa é a gama do L2 Pro. Qualquer um desses equipamentos vai trazer a mesma precisão e vai trazer a mesma qualidade, aí o que difere de um para o outro é a quantidade de pontos por segundo que captura e o alcance dessa captura. Mas os três são equipamentos fantásticos, de uma qualidade de construção enorme, né? O material, a gente percebe que é um material de altíssima qualidade, isso se reflete também nas entregas do scanner. Então, são equipamentos aí de última geração que a gente está trazendo em primeira mão, e estamos muito felizes porque isso vai mexer com o mercado brasileiro de scanners SLAM, né? A gente está falando de uma categoria de scanners que é recente, né? Chegou recentemente no nosso país. Antigamente a gente tinha somente outros scanners estáticos, né? E os SLAMs chegaram há pouco tempo. E agora a gente traz o XGRIDS, que na nossa opinião é o melhor do mercado. A gente vem já testando e utilizando esses scanners aí desde o início desse ano. A gente passou por um período de bastante cuidado com a avaliação e a confirmação de tudo que a XGRIDS apresenta para a gente, e a gente conseguiu comprovar isso em diversos projetos, e a gente vem tendo resultados fantásticos, e agora chegou o momento da gente conseguir compartilhar isso com toda a nossa comunidade de geotecnologia, de captura da realidade. Isso vai desde usos para construção, arquitetura, topografia, e também a parte de produção de vídeo, né, produção de audiovisual, onde a gente consegue utilizar o resultado desses scanners também para poder criar esses ambientes virtuais e integrar isso, né, otimizando o custo, diminuindo até mesmo o impacto ambiental que a gente tem com transporte, com, enfim, várias situações aí que a gente vai conseguir evitar, né, fazendo essas digitalizações, fazendo a captura da realidade. Então, resumindo, isso, a gente falou da empresa, a gente falou dos scanners, das soluções, né? Nós vamos começar agora a fazer uma série de vídeos onde a gente vai trazer casos, né, de utilização dos scanners, vamos trazer mais detalhes aí sobre cada um dos scanners, tudo isso já em português, para que fique mais fácil da nossa comunidade absorver. Agora, não sei se tem alguma pergunta, eu acho que a gente não tem perguntas. Eu vou, então, nós vamos encerrar, não sei se a Mindy quer fazer algum comentário, eu vou perguntar para ela. Senão, nós vamos encerrar. Essa webinar vai ficar gravada para vocês poderem assistir depois. A gente vai colocar as legendas em português para poder facilitar. Qualquer dúvida que tiverem, vocês podem falar com a gente. E a gente vai estar auxiliando. Bom, Mindy,
Hi.
there are no questions so far. I don't know if you want to make a final comments. Just gonna go ahead if you have. If not, I'm gonna just do a
The recording.
invitation to the event that we have now, the Mundo Geo Connect. If you want to comment.
Yeah. So firstly, I must say, appreciate that's all your translation and invitation. And it's my first a chance to get cross language webinars. And I'm sorry that make it too long. So maybe next time I will make it much more easy and short. And thank you for this chance. And if you got any questions, you could leave a comment, and we will answer that not only on live, but also with that all the comments or question answered after all the webinars recorded and uploaded to your platform. Yeah. So will you that make that webinars in YouTube or different channels?
Yes.
Great. Yes, thank you for that application and the plugs.
All right. Thank you, Mindy.
Yeah, you're welcome.
Bom, então a Mindy estava falando que ela é a primeira vez que ela está fazendo um webinar aí com duas línguas, né? Rodando ao mesmo tempo. Então, agradeceu pelas traduções aí e disse que está muito feliz aí de ter feito essa apresentação. Qualquer dúvida que tiverem, vocês podem entrar em contato, tanto a Mindy quanto a gente da Plankus também vai estar respondendo essas perguntas aí através dos canais. Então, vão ficar publicadas o vídeo. Vocês podem adicionar aí nos comentários todas as dúvidas que tiverem, a gente vai entrar em contato. Vamos, então, né? A gente está agora no dia 2, amanhã, de 3 a 5 de junho, acontece aqui em São Paulo, a Mundo Geo Connect, que a gente já está aqui em São Paulo para poder participar da feira. É o maior evento de geotecnologia da América Latina e nós estamos no stand 311, fazendo, né, a apresentação dos scanners da XGRIDS e dando todo o suporte necessário para quem queira conhecer, para quem queira fazer a aquisição dos scanners. Então, não perca. Quem não tem ingresso ainda, né, se quer ir lá e não tem ingresso, pode falar com a nossa equipe. Entre em contato com a gente através de contato@plankus.com e a gente vai conseguir esses ingressos para vocês. A gente tem ingressos cortesias disponíveis para quem são clientes e parceiros nossos. Então, obrigado a todos pela audiência e nos vemos na Mundo Geo e nos próximos vídeos que a gente vai começar a lançar agora, mostrando todas as soluções da XGRIDS e da Plankus. Obrigado, pessoal. Tchau. Bom dia.
Bom dia.